So I'm Chris Wu. This is my second semester in Nest, and I was one of the 3 students doing Hacker Academy. Hey, the module that I was assigned was server attacks. Server attacks had protocols and basics and some other labs discussing how to do password cracking and some other basics. This lab was very on the surface. There was not really too much in depth. It was mostly coming over and introducing you to material. The first lab was the lab to tell you how to do your ABCs. In this case, HTTP, SMTP, and FTP. And hypertext transfer protocols, simple mail transfer protocol, and file transfer protocol, which can be a tongue twister. The first lab relating to HTTP, he was using a sniffer and looking at packets as you click through your links of maybe your less than legal websites, or YouTube, and figuring out which header fields and match it to the reference handbook that they link to. And then they expect you to glance at the reference handbook, kind of figure out what you want to know, or try to figure out what you want to understand is based on you of how you want to learn this lab. Otherwise, they said, try this. This was sniffer. The SMTP lab was a little longer than HTTP. Instead of just Wiresharking my way through different websites, I was expected to use NCAT and Telnet from the Linux computers. And the FTP was mostly just a thinking lab and looking up what's the difference between passive and active FTP. So a little more into the SMTP lab. This is like the steps to send yourself an email if you ever so need. It's all text-based, no images. Well, you can do YouTube links if you really want to type in that huge URL. So using your NCAT or your Telnet, you are to NCAT your destination domain to port 25. That is the mail server in the SMTP protocol, or using your Telnet. And once you connect, you're expected to have a greeting. And then you're supposed to say hello, because it would be nice if you respond to the computer and they don't shut you out after some amount of time. If you never reply, they will close you out because they don't want to leave that port open. Depending on computer systems, though. If they're bad, they're going to leave that port open for a long time. Once you say hello, I am from, let's say, nest.unm, you get a reply code. And now you kind of put your header for your email with maybe your email address, example@unmnest. Did I do that backwards? I think I said nest unm first. Anywho, another reply code, who you want to send it to, from that domain, and whatever you want to put in your message. And you expect to get a reply code, a confirmation that you sent it, and then you quit. That was pretty much the lab. And it was not very exciting because the reference handbook are dictionaries in themselves. The FTP lab was the discussion about how FTP worked, read the reference handbook, and figure out what active and passive is. The active FTP is an older version where attacks were not as commonplace, where there's not a lot of script kiddies and there's not YouTube describing how to hack my email. Hackstore at 21 no scope. And the active FTP had client established connection with the server, and the server established connection back, saying the connection is from client and the server back. Passive expects the client to establish both connections, going like the command and data ports. And this is to bypass firewalls, because firewalls sometimes have to be configured where the server will get rejected when it sends in its request to figure out a port to send data back in. And this is a bypass, so your computer is obviously safe and everything going out is not a danger to your computer. And if you ever wanted to figure out these reference handbooks and read the dictionary, go for it. This is another short lab. It was an explanation of buffer overflows, exploitation of buffer overflows, and explain a little bit about exploitation coding using C. And explains how some exploits work and how they insert shellcode using buffer overflow. If you want to find out more, you can read Smashing the Stack for fun, and you don't want to listen to my TLDR of it. But what it basically says is that we're going to send a huge buffer into the small box and keep filling it until it's just filled with junk. Then we start adding our shellcode in, where we change the pointer to the shellcode and have it execute from there. And they included this nice short Stack Overflow code. It does nothing but give you errors if you were try to run it and expect something to come out of it. Now this one's actually an interesting lab, and this one's not just read the book. This one's more of introducing Hydra and Medusa, two different types of password crackers. And by different, I mean they have different ways of running it. They do the same goal, but each one has their own speciality. They're both available on the same kinds of machines. So if you feel like you need one or the other, just get both. They're fine. The difference between Hydra and Medusa is that Hydra uses a fork. So when it runs a process, it copies that process, everything in it, and runs it again with different parameters and keeps going over and over again. But Medusa was like a better version of Hydra, with the sense that Medusa wants to actually run those multiple processes. So what Medusa does, it runs a pthread based. It takes your word list, because you don't need 1,000 of those, and just shares it between every process. So that process is a little more efficient depending on how big your list is. It could be incredibly large, incredibly small, or whatever. And since it's a little newer, it's not as old as Hydra. As Hydra gets older, it's a little more outdated. Medusa is newer, so it's stable, but they're both open source. No, wait, Hydra's open source. Medusa is not open source. It was someone who used Hydra who wanted to use Medusa. If you want a chart of every difference, of every change in hair, you can look at the link where they have different run times of different scenarios, and they give you a timer on them. This is what Hydra and Medusa supports in trying to crack down. There's a lot in Hydra and a lot less in Medusa. But they're both pretty important tools to password cracking with brute force. Hydra's parameters and Medusa's parameters have slightly different syntax. They both have, the username list and your password list. But Medusa also includes the number of threads to run, whereas not needed in Hydra. Hydra instead just requires you to have all the lists, the password, and the URL, and the name of the username field, and the name password field, and name of login field. And those things are super case sensitive. You get one letter wrong, you're waiting an hour for like a 10 password. Oh God, it was terrible. Medusa, on the other hand, is a lot shorter, still case sensitive. But Medusa can be a lot shorter if you run hundreds of threads doing the same thing, coming at it and running your different types of services.
Quick question.
Yeah.
So you can't use a password list with Medusa?
Yeah, password word list.
Sorry, username list.
Yeah, it's a capital U.
Okay.
Yeah, I guess I wasn't sure how many case-sensitive stuff I was supposed to do.
So you could have a username list and a password list, and it would run each username with all the passwords?
Mm-hmm. This is specific to the lab, so I put those down. Actually, I should have gone over that. Note to self, actually change that. Hydra and Medusa include capital letters. Okay. Since Hydra's a little older, some links are broken when you go to their nice little wiki page, in a way. Hey, Medusa is a lot harder on the eyes, it's kind of dark, but since it's newer, most stuff is actually relevant. Finding and using exploitation information. This lab is currently bugged, but this lab is all about finding the exploit that is related to your target This one kind of puts together your social engineering and other modules, and this is the part where you want to send your exploit. Since Hydra's a little older, some links are broken when you go to their nice little wiki page in a way. Hey, Medusa is a lot harder on the eyes, it's kind of dark, but since it's newer, most stuff is actually relevant. Finding and using exploitation information. This lab is currently bugged, but this lab is all about finding the exploit that is related to your target. This one kind of puts together your social engineering and other modules, and this is the part where you want to send your exploit. You need to research your system, research the current model, and everything you need to figure out what is its weakness and figure out the exploit. The nice thing about Searchploit is that when you type in your target, like Adobe Air 08, I don't know if that actually exists, it'll give you a list of it if it's in your database. But you also need to update your database if you want to ever find any of those things. And using exploit in example, because in particular lab they use a lot of Python script. It's Python, your script name, your directory of keys, where you find your list that you want to try, the host, the username, port, and threads. And there's another password cracker they introduced was the John the Ripper. John the Ripper is more for an offline, because after you dump the hashes is where you want to use John the Ripper, versus Hydra and Medusa where you want to attack a web page or somewhere that you don't really have the hashes. Password hashing takes your string of characters of 1, 2, 3 and changes them to another string in some kind of coding like alphanumeric shifting, so it's ABC, A plus whatever. And they try to keep it unique so that passwords don't overlap. So if you happen to plug in 456, it's not also ABC. And they store that hash into memory. But after a while, hashing started getting breakdown because everyone using the same hashing. So now every computer adds their own salt. And with a salt, every computer or system has their own kind of add-on or padding to change that ABC or 1, 2, 3 to be like 1, 2, 3 example is a salt. And changes the hash to be something completely different from what you originally plugged in. And makes brute force techniques harder because now you have to figure out the extra words that are not part of the string or password that you thought it was. There are 4 different password cracking methods. There may be variations thereof. Common one is a dictionary word list, where you have the page on page of figure out every word that you might think is possible. Well, like someone's birthday, someone's eye color, someone's wife, someone's husband, someone's hidden something. Okay. Or use pre-computed hash tables, which is basically if you know the system you're attacking and you know the type of hash it's going to use, then you can just kind of use that hash and find the relationship between every word. Like if you know ABC is 1, 2, 3, then every time you see 1, 2, 3, you can say there's an ABC in that password, assuming you know the salt too. And then you have brute force, which is the guaranteed way of breaking it, but it also takes forever depending on the password size. And then you have a hybrid, whereas adding like leet speak, where like our password here is like recalibrate. They have like a 3, an at, and a 7. No, we have 3 and at. Yeah, had to replace common letters, or appending birthdays. In years that might be related to the password. John the Ripper runs on most OS. It's similar to Hydra and Medusa. That should be another tool in your kit if you want password cracking. It's free and open source. Here's a link. And it's also community enhanced. And so the word list that comes with John the Ripper, you should probably change that to something the community has, even though that word list may be a little more specialized than what you're intending. The community also has like updates or other add-ons that you feel like is useful for you. John the Ripper is effective in using its word list dictionary and being very fast with it. You're allowed to add rules to it, so you can say, oh, I know that passwords don't accept spaces, so I'll take out all the words with spaces. Or I know that this person likes this number, and I can add this rule in using another list. The developers for John the Ripper also include statistics. So the word list they included, it was a statistical based on passwords of Windows XP, maybe, or something outdated. But the John the Ripper also uses this brute force, this statistical analysis, and kind of learns as it goes, saying that I've been seeing a lot of these passwords. I'm going to start adding this to my list, or I'm starting to try this more often. It's not always brute force where it goes A, B, C. It might go from A to AZ because that AZ might be more common than AA. The syntax for John the Ripper is pretty straightforward. You John your hash file, whatever you dump from your target. You specify your word list, and then you add your rules, which can be some default, which is what on the string, and then you can show your successes and write your successes to a file, which is a .pot file. And the last lab, or module, Discombobulating a sock. It uses a combination of Syslog and spoofing a Syslog using Scapy. Scapy is one of those free open source tools that you can use to manipulate packets. SOCs, or Security Operations Center, attempts to figure out what could be threatening. And they are your police force. Oh, not your police force. They're your mall cops. They're the guys who try to stop things as they can, but in reality, they may have all the power and may not have any power, or in the sense that they can either turn off the system or they can just alert the real police. They try to flag suspicious activities to try to figure out what is happening to their system and can they stop it? Maybe. So there's three parts to a syslog message. There's a PRI, which is has a priority header, and the priority value is made by multiplying a number. If you want to decode it, you divide it by 8. You get the integer value, and then you multiply the integer value by 8, subtract it from to get the severity. The facility part is where it's taking place and what machine. It depends on what SOC assigned what values to what. Right? And the severity also can depend on how bad it could be. So you have to look up on your target to see how they assign things. If it's default, it's probably just like main computer, Susan's computer, James' computer area. If there's also more in that text header. And in the header, it contains timestamps and hostname IP address. That's where it says this is where it's happening at this time, but it can be slightly different depending on their standard. If it follows the RFC standard, where it has the time and IP address, you can trust it to be like that. And the message where it could be login failed or panic, hit the power button now, John. It very depends. These are very, customizable in a way. The problem with the mall cops is that there's too much trust in the syslog. As long as you get the syslog syntax right and you don't misspell stuff like those bad spam emails, they will trust into it and saying, this is happening right now and this could be a problem. And it kind of goes in with the social engineering tactic where if you know your target and you know how to manipulate them, you can start pushing them towards restarting the system or turning off a particular computer. Or you can start pushing them towards actions that will be favorable to you. And how do you fake a spoof log system? Use Scapy. And Scapy is pretty long in syntax. It's the second line. It's the long-ass character where it includes the destination IP, source IP that you're spoofing it from, and what kind of package you want to send it from whatever port to destination port, plus your text. And then you can send as many as you want. You can do times 1,000,000, though that would be both a strain on your computer and the other computer. get to a certain point. And that's about it. Any questions?
So when you were talking about John the Ripper, are those rainbow tables? Instead of pre-computed hashes?
Pre-computed? It depends how you dumped it, I would think.
Well, what you're comparing it to, though, because you're comparing hashes to hashes, right?
Yes.
So,
Rainbow tables. What tables do they use? I don't remember.
like when you download a word list,
Mm-hmm.
I don't see it. Like, I guess what I don't understand is how do you go from a hash to a word list? Like, how do you compare them to? Like, it would have to be a bunch of hashes already, right?
Character where it includes the destination IP, the source IP that you're spoofing it from, and what kind of package you want to send it from whatever port to destination port, plus your text. And then you can send as many as you want. You can do times a million, though that would be both a strain on your computer and the other computer. Get to a certain point. And that's about it. Any questions?
So when you were talking about John the Ripper, are those rainbow tables? Instead of pre-computed hashes?
Pre-computed? It depends how you dumped it, I would think.
Well, what you're comparing it to, though, because you're comparing hashes to hashes, right?
Yes.
So,
Rainbow tables. What tables do they use? I don't remember.
like when you download a word list,
Mm-hmm.
I don't see it. Like, I guess what I don't understand is how do you go from a hash to a word list? Like, how do you compare them to? Like, it would have to be a bunch of hashes already, right? Because you're searching for hashes in a batch, or no?
What it's trying to do is trying to find, like, it will try different hashing techniques. So you have the hash file, and it'll try translating it in a way. It's like an unknown language, and it wants to figure out how that language syntax works. So when you have the hash file, it kind of puts letters through it in a way. Also, they were really not specified about John the Ripper.
Okay, cool.
Hold on, let me think about it. I'm trying to remember the lab. I did this like a week ago, so my memory's a little bit shot. So what it does.
Like, what did you do in the lab?
So we use the write the results to file and just check the results of what it could be, trying those passwords. I'm guessing it's trying common hashes, and I'm thinking using default, like LM or NLM. I think I got that one wrong. And try to use default hashes to figure out what those letters are, comparing them to the hash file of what we got.
Oh, okay, got you. Cool.
I could be wrong on that. All right.
Thanks.
Anyone else? No? Pretty good?